All right, welcome back, everybody. We're going to continue on with your exploration of how we simplify exponential expressions now that you have reviewed your grade 9 exponent laws and also now have added on to that rational exponents from 4.3. You're now ready to begin 4.4. So make sure you really do understand 4.3 before you try to do this section. It'll help a lot. So what I'm going to take you through now is how do we actually put it all together. So I have 4 examples here basically of the different types of questions that you can come across and how I think is best to approach them. You don't have to do it my way, but I'm always going for the most easiest way and the way that's probably going to lead you to get confused least often. So the suggestions I make are just that. Just suggestions. Obviously, you're always going to show your work, regardless of what order you decide to go with when you do simplification. So one of the ways in our minds on here, our intro in this lesson, is we can put 2 expressions back to back, and that is called a ratio. And one of the more common ratios in science and biology specifically is surface area to volume. So when you have a cell, it needs to not only get in nutrients, but it also needs to expel wastes. And the more opportunities, meaning the more doorways, right, the more exposure to the outside that it has, meaning the higher the surface area for a lower amount of stuff inside the cell, meaning a lower volume. So a high surface area to volume ratio means that it's going to be really effective at getting in what it needs and removing what it doesn't want anymore. So we have, assuming spheres are our cells, we have the surface area of a sphere, 4 pi r squared, and we have the volume of a sphere, which is 4/3 pi r cubed. What we want to do is to determine the surface area to volume ratio of the cell. And that dot dot means 2, and that in math means divide. So what we're going to do is we're going to put the surface area expression on top of the volume expression. The surface area expression was 4 pi r squared, and the volume expression was 4/3 pi r cubed. So I could just give you this to start with and say simplify that. Well, my suggestion is to undergo the following steps when you do any kind of multi-step simplification. Do you have any double exponents? If you do, apply your power rule. Okay, so that is where you times the exponents together to bring everything down to a single exponent on a single base. Then you're going to look across rows, so row by row, and you're going to combine like bases. So that means you're multiplying row. So with that means that when you're multiplying and you have the same base, you're going to add the exponents, right? And then you're going to look top to bottom. So top and bottom together. So you're going to combine again like bases. And that is called your division rule. And then last, you deal with negative exponents. And you learn that you flip the base to its reciprocal. Ran out of room there. There you go. To its reciprocal. So that would be the order that I would personally do every question in. It's a set order. It always tends to work. So in this case, if I was given this to start with and I was told to simplify it, do I see any double exponents? No. The r has a single exponent. This r has another single exponent. So this doesn't apply to this question. Row by row. Can I combine anything together on the top row? No. They're all different from each other. All the bases are different. 4 is a number. Pi is a number. R is the only variable, but there are no other r's for me to put with it. Same thing on the bottom. There are no other extra r's on the bottom to go with this r. So this doesn't apply to this question. Now we look top and bottom and we combine like bases. So numbers go with numbers, numbers go with numbers. So pi can go with pi, and obviously those can cancel out. And radius goes with radius, and we subtract those exponents, right? So 4 divided by 4/3. If you're not sure, that's what we're doing. We're going 4 divided by 4/3, so we go 4 times 3/4. 4 cancels out with 4 if you want to do it that way, or it's 12 over 4. In the end, you get the answer 3. So we know that that's going to be a simple 3. So 4 divided by 4/3 is 3. Pi divided by pi is 1. That goes away. And r squared divided by r cubed is r to the whatever 2 minus 3 is. So it's top exponent minus whatever the bottom exponent happens to be. So we have 3r to the negative 1. So now we've done step 1, step 2, step 3. Last step, negative exponents. Do I see a negative exponent? Yes. We don't like leaving our answer like this. So what we do is we flip the base that the negative exponent is sitting on. The 3 does not have the exponent on him. I repeat, the 3, there's nothing wrong with the 3. The 3 stays where he is. What's going to happen is the 3 is going to stay where he is, and the r becomes 1 over r. Because remember, there's a 1 underneath that r that nobody writes. So what happens is the r gets flipped, and that uses up the negative 1 exponent, now becomes a positive 1 exponent. So what's really going to happen is 3 times 1, which is 3, and the r is just going to slide underneath. Most people like to keep them all together and compact instead of two separate portions like that. So what this means is your surface area to volume ratio is 3 divided by whatever the radius of the cell is. And the higher this answer, the more efficient and effective the cell is at obtaining nutrients and expelling wastes. So this is the simplified version of your surface area to volume ratio. So using these same steps, we're now going to do these 4 typical questions that by the time you get to 4.4, you should be able to do. So if you didn't print this out, that's fine. You don't have to. It's only 4 questions. Copy them out as best you can and do them along with me, or try to do them ahead of me and then come back and listen and see how well you did. Okay, so simplify this expression. We have negative 3 to the exponent negative 2, y to the power 4, all cubed on top, and then 2x cubed y to the negative 7, all to the power 5 on the bottom. So, equal sign. Step 1, double exponents. Yes, definitely. Everything on top gets cubed, including that negative 3. So, that cubed goes on everybody, not just the letters. So, the negative gets cubed. The 3 gets cubed. So a negative to an odd exponent is going to be negative. 3 to the power of 3 is not 9. 3, 9, 27. Double exponents get multiplied. So negative 2 times 3, negative 6. 4 times 3, 4 groups of 3. We're going to get a total of 12. So now I've gotten rid of the double exponent on top. There's another double exponent on the bottom. That 5 again belongs to everybody who's in that bracket, including the 2. So this is 2 to the power 5. It's helpful if you ever memorize that. Find that is a very useful one to memorize. So then you know 2 to the power 6 is 64 right away, because you know 2 to the 5 is 32. Oh, why did I write 35? 32. So 2 to the power 5 is 32. 2 to the power 4 would be one level under, so it would be 16. So you divide by 2. When you go down, times by 2 to go up. So 2 to the power 5, 32. Double exponents get multiplied. 3 times 5 is 15. Negative 7 times 5, negative 35. So we did step 1, double exponents done. Step 2, top level. Can I combine anything? Nope, nothing matches. Bottom level. Can I combine anything? Nope, nothing matches. So step 2 doesn't apply. Top and bottom together. Numbers with numbers. Can I reduce 27 and 32 just as a fraction on its own? I don't think so. I can't think of anything, only 9 and 3, and those don't go into 32, so you're kind of stuck with negative 27 over 32. However, the x's go with the x's and the y's go with the y's. So negative 27 over 32, we can drag it out to the front if you want. Negative 6 minus 15. Negative 6 subtract 15 is negative 21. 12 subtract negative 35. And again, if you're somebody that needs to see it, I would highly suggest you get into the habit of writing it out. Top exponent minus whatever the bottom exponent happens to be. So this is 12 plus 35 when you work it all out, and that gives you 47 on the y. So we have an issue. Last step, negative exponents. I do have something now that has a negative exponent still on him. So that means he needs to flip upside down. Instead of x over 1, he's going to become 1 over x. He's going to slide as an x next to the 32 who's already in the bottom. The y does not get flipped. The y has a positive exponent on him. He stays in the numerator where the 27 is sitting. So the cleaned up version and your final answer would look like negative 27 with a y to the 47 sitting on top, 32 x 21 on the bottom. That is the best looking answer you're going to see. That negative sign in front of the 27, it could be in front of 27 or it could be in front of the entire fraction. As you know, nobody owns a negative in a fraction. Okay, so again, that's us applying those 4 steps to that question. Question 2 says, simplify, then evaluate, or sub in and then simplify. It gives you what x. If you didn't know what x is worth and what n is worth, you would just deal with the x's as x's. And again, we're going to go through our steps. So I'm going to do this on the back here. X to the negative 2n minus 1. And x to the negative 4n over x to the 3n minus 5. So this is what the question came to us looking like. So if we were going to answer this, not replacing x and n, but simplifying, we would go through our steps again. So do you see double exponents, meaning another exponent outside these brackets? And the answer is no. So the power rule doesn't work in this question. Don't need it. Row by row, top row, can we combine anything? Yes. This x and this x can be put together using our multiplication row, where we keep the base and we add the exponents. So this exponent plus whatever that exponent happens to be. On the bottom, there's nobody that can go with that x, so he just sits and waits. So let's clean up the top. Negative 2n plus negative 4 more n's. So on that x, we have a total of negative 6 n's, and then just a minus 1 because he had nobody to combine with. So now we're at the point where we have a single base on top and a single base on the bottom. We now need to combine these using our division rule. We're going to take our top exponent, negative 6n minus 1, and we're going to minus then with a bracket because we're minusing 2 things here. We're minusing whoever is underneath. So we're minusing 3n, subtract 5. So again, doing proper polynomials and distribution, that minus goes to everybody who is in the bracket after. So negative 6n minus 1 minus 3n positive 5. And that's where students are going to go wrong right there. It's not putting the positive in front of the 5. So of course you clean that up. Negative 6n minus 3 more n's is negative 9n's, and negative 1 plus 5 is a plus 4. So there's your final simplified answer. Once you get down to this point, then you can sub in what it told you. X was negative 3 and n is 2. So once you complete and you do all of that simplification, just replace the letter x with a negative 3 in brackets. It's negative n 3. And then negative 9 times n becomes negative 9 times 2 plus 4. So negative 3 up to the negative 18 plus 4. Negative 18 plus 4 is negative 14. So now we're actually getting an answer. All right. Negative exponents means that we flip the base to its reciprocal. It's still negative as a base. So negative 3 over 1 becomes negative 1 over 3. That's now a positive 14 exponent. Okay? Negative to an even exponent, so a negative repeated an even number of times means that they're all going to pair up and go away. A negative times a negative is a positive. So every time they pair up, they're gone. So because 14 is even, everybody's going to pair up with somebody. So all these negatives are going to go away, and you're going to be left with a positive answer. So I'm just going to put a plus sign there just to make it obvious. 1 to the power of anything is 1. That's never going to change. 3 to the power of 14, though. If you try this in your calculator, you're going to get 4,782,969. There we go. And that's your answer. So 1 over 4,782,969. And that's it. You're done. So that was simplifying first. I wanted to show you how to do the algebra. So you can apply your grade 9 exponent laws to algebraic statements, and then you submit at the end. Okay, now on to number 3. Again, we now have these fraction exponents. So I know it looks really small here. So it says simplify. And then in brackets, 729, a to the negative 3 exponent, b over 3. On the bottom, in brackets, 36, a to the negative 8, b to the exponent 12, to the exponent 1/2. And you learned that 1/2 means square root by now. So what we have here is, again, to do our rules here in order, getting rid of double exponents, then looking at each row independently, then combining the rows, then dealing with negative exponents. Do not start flipping things. I repeat, do not start flipping things. Don't see the negative exponent on the a and the negative exponent on the a down here and start replacing and flip-flopping them. That is not the proper order because we have an outside exponent that needs to be applied first. So this 1/3, he's going to go to everybody. Now, as you learned, the bottom of the exponent, so when it's a fraction, the denominator goes to the front. The numerator goes to the back. And that is how you actually show you your work that you're actually going to solve for whatever the cube root of 729 is. We'll use our calculator in a bit. Then we have double exponents, a to the negative 3 to the 1/3. So this is me showing my work. Some of you are going to write down your answer right away, and that's fine. I'm just showing people how we're getting this final answer. This exponent times that exponent. So now we're timesing fractions. We're multiplying fractions together. On the b, we have a 15 originally, and that's now going to be times by 1/3. On the bottom, we do the same thing because that 1/2 now goes on the 36, better known as square root of 36. You don't have to put the 2 here. Again, when you square root a number, the 2 is automatically known to be there. On the a, he came with a negative 8. He's now going to be times by the 1/2. That is outside. And the b came with a 12, and he's also going to be times by the 1/2. So now let's figure out the number answer. Cube root of 729. So hopefully by now you've realized that you should have this button on your calculator. For me, it's the second function of my exponent, where it's x root. Some of yours might say x root y. Some people might say y root. This allows you to take any root of any number. So the x means it can be anything. I want it to be a 3 in this case. So 3, then that number, then 729 on the inside. Yes, I know I also have a cube root button, but that's only good for cube rooting. This button is good for everything. So you're going to need to use this button regardless for other questions. So the cube root of 729 is 9. That means 9 times 9 times 9 gives you back 729. So let's replace this with a 9. Now, that answer was put to the power of 1, which we know is just 9. So I don't even have to finish that part. Top times top, bottom times bottom, 3 times 1 over 1 times 3. Negative 1 on the a. top times top over bottom times bottom. 15 times 1 over 1 times 3. 15 over 3 is 5. Square root of 36. We'll just take the positive answer of 6. Negative times positive is negative. 8 times a half of 8 is 4. A half of 12 is 6. So now we've dealt with the double exponents. There's nothing to clean up on the top row. There's nothing to clean up on the bottom row. So now we clean them up, top row and bottom row together. So that means number with number, letters with letters, right? So 9 over 6. Well, we're not going to keep it as a 9 over 6. That's going to be 3 over 2. Negative 1 minus negative 4. So again, people that need to see it should write it out so that they don't screw up on the integers. Negative 1 subtract whatever the bottom exponent happens to be. Happens to be a negative. So that's negative 1 plus 4. So look at that. We get a positive 3 out of that guy. 5 minus 6 on the B. 5 minus 6 is negative 1. So now we look at this final answer and we think we're done, but we're actually not done because that B shouldn't stay like that. You see that he has a negative exponent on him. He needs to go underneath and sit where the 2 is sitting. That's putting him in the denominator. And that's going to use up the negative by flipping him under there, and it's now going to become positive 1. So nothing wrong with the 3, nothing wrong with the A. They all stay in the numerator. Don't flip them. There's nothing wrong with them. Nothing wrong with the 2. He still stays underneath. Joining him is going to be the B. You can put the positive 1 or you can leave it out. Doesn't really matter. So that's the way we would properly show our final answer with only positive exponents. So that's what you do when you see these complex ones where they have outside fractions and so forth. Lastly, what do you do when you see radicals? So we have the 6th root of 8 x to the 6 all squared, and then the 4th root of 625 x8. So this can look very, very confusing and complex, but it's really not if we actually put it back into exponent form, and then we do our steps in order. So underneath, the radicand was 8, 6, we have a 6 and a 2. Now remember, when we put this back as a fraction exponent, the number that was in front came from the bottom of the fraction. The number that's in the back came from the top of the fraction. So that's just me putting it back in exponential form. This is radical form. I'm going to do the same to the bottom. 625x8 and 4th root. So there's a 1 back here that nobody writes. He's back there. So this must have been a 1 over 4 exponent. That's why he ended up looking like the 4th root. So this just becomes now like the previous question. Apply the outside exponent to everybody inside and then clean it up. Now 1 over 6, 2 over 6 is the same as 1 over 3. So that was reducible, so I am reducing it. So this becomes the cube root of 8 to the power of 1. I can put that there. And 6 times 1 over 3. So 6 times 1 over 3, double exponent. 6 times 1 over 1 times 3. That's going to give me x squared. On the bottom, 4th root, 625. And then top times top, bottom times bottom on the x, 6 over 4. I'll just keep it as 6 over 4 for now. We can reduce that to 3 over 2 if you like. Let's go back to the top, the cube root of 8. So if you didn't know that, 2 times 2 times 2 is 8. So 2 cubed is 8. So 2 is the cube root of 8 to the power of 1 is just 2. So 2x squared over 4th root of 625. So if you didn't know that, 4th root, so back to that x root button, 625. 5 times 5 times 5 times 5 gives you back 625. So 5, and then x to the 3 over 2. So now we're at the point where we have a 2 on top of a 5, not an issue, and an x squared, though, on top of an x to the 1.5. So that means that we should combine our x's to finish this off. So 2 over 5 stays. We don't have an issue with 2 over 5. But on the x, 2 subtract 3 over 2. top exponent minus bottom exponent. So now you're subtracting fractions. So now we actually have to figure this out. So 2 take away 1.5, I'm assuming this is a half. But if you wanted to get common denominator, this would become 4. This would become a 2, right? So 4 over 2 minus 3 over 2. I'm showing all my steps here. 4 over 2 minus 3 over 2 is 1 over 2. So that's all nice. That's all well and good. We don't like it as a decimal. Don't use 0.5. However, you're probably not going to see this written in the back of the book like that. What you're probably missing is this 1/2 exponent on the x. He's going to look like this, right? With the 2 magically in the front that nobody writes because it always means square root if you don't see any other number. And the 5 on the bottom. So that's probably the way you're going to see it written most likely. The 5 could be just under the 2 or under everybody. It doesn't matter. But keeping it as a fraction exponent doesn't look as nice as if you write it like a radical. So that's a prettier final answer. All right, so that hopefully will help you put 4.3 and 4.2 all together in your mind in order to help you do 4.4 simplifications. And if you keep these steps in mind, I find that that makes it the most easiest when you attack any problem. All right, so let me know if you have any problems with any of the homework questions out of the textbook. They're definitely worth your while. And you do have a quiz coming up not too long from now. So it's important that you get on top of this, you stay on top of it, and you do all the practice. All right, talk to you soon.